friendly group. Our first speaker is Jamie Cross with the Alliance for the Great Lakes, and she is talking about abundance and environmental drivers of anthropogenic litter on 5 Lake Michigan beaches. Huge title, but a huge problem too, and so let's give Jamie the floor.
Okay, so let me know when you want me to go.
Yep, we're almost there. We'll just figure it out. You want the clicker?
I think so.
Yep, remember to talk to the microphone.
Uh-oh, somebody embedded some.
The virus.
Yeah, it's a virus. So good morning. I'm Jamie Cross. I'm from the Alliance for the Great Lakes. I'm the Adopt-A-Beach manager. Real quickly, I'll tell you who the Alliance is. For those of that you don't know, we're headquartered in Chicago. We were founded in 1970. Most of our staff are in the Chicago office. We also have staff throughout the region. I'm from our Grand Haven, West Michigan office, and we work on 3 levels. So we work on policy, Great Lakes policy, making sure there's good protections in place. We have curriculum, it's K through 12, Great Lakes in My World, and then we do stewardship, and that's where my role comes in through the Adopt-A-Beach program. I'm going to give you a really quick overview of Adopt-A-Beach because I'm sure many of you are familiar with it. But it's a volunteer program in which we have teams of volunteers throughout the Great Lakes, now on all 5 Great Lakes, all 8 Great Lakes states, and they go out year-round to remove litter, and they don't only remove it, but they actually record what they find. So there's a sample of a data collection card here. This is also used throughout the world with volunteer programs on cleaning up shorelines. I left some in the back so you can see it more clearly, along with one of our newsletters. And then after they're done, they actually enter the results into an online system, and that online system is where we can pull data out and also the public can. Today I'm not here to talk really about the Adopt-A-Beach program. I'm here to talk about the data and the analysis that was done by Loyola University, and the principal on that was Timothy Holin, Dr. Timothy Holin, and he will be here tomorrow too. There's a panel tomorrow on microplastics with a number of the researchers that have been highly involved, so please, that's tomorrow. And he worked with 2 of his students along with the Alliance for the Great Lakes. And so kind of important to know that there's a lot known about the accumulation of litter in ocean communities. We hear about the garbage patches, you hear about ingestion of, sea turtles or entanglement issues. We know about decomposition in oceans, but really the Great Lakes lags behind in this information in terms of fresh water. We're quite different. But there's a lot of research that is currently ongoing, and today I'm here to talk about the data that we collect and what Loyola has done to look at it in a freshwater system. So the reason why we count litter. We want to learn about the sources of the litter in the Great Lakes and the fate of the litter. We also want to measure the lifespan impact on living things and develop efficient and effective methods, and so we can reduce the litter process. So this is well on its way in ocean communities, and I have to say that it's on its way in the Great Lakes because of the great research and some other things that are going on now in the region. Today I'm going to mainly focus on a project with Loyola University, doing analysis of our data, but I'm going to mention another project they're working on now that will have complete results, or they're going through analysis of that data right now. So the first study project started actually, is the name of the title of the presentation today, but it's actually a little different. So there are, Loyola they took 5 of our beaches on Lake Michigan and used the data. It had to have, those beaches had to have a certain amount of data. They were rural and some were very urban, like Chicago beaches. And so that's resulted in a white paper, a peer-reviewed paper, and I think last year it was completed. And the outcome was simply that most of the litter that we were finding on the Lake Michigan beaches combined is food related and smoking related. So in ocean communities, it's different. They're looking at fishing related debris and other things in ocean communities. So we're different. were recognizing than ocean communities. So then Loyal wanted to look at a second, after they completed the analysis of the 5 beaches, they wanted to look deeper. And so now looking at the fishing activity, does it impact litter in the Great Lakes? And do rivers in the proximity to the beaches impact, make an impact also? And this was really interesting to me too, because I've been very interested to see how rivers impact. These are the questions that they wanted to ask. So the first question, so the study sites included more than 200 locations. Each of these study sites had to have data that had 5 events or more of data collected, and they had to have GPS coordinates of both the starting point and end point of the beach so they could look at area. So the first question was, with all Lake Michigan beaches, all these beaches that they were looking at, does fishing make a major contribution to the litter? The prediction was yes, it should, based on what was done in the ocean communities. So here's the comparison. So we're looking at, on your left is the fishing beaches. And I'm going to define fishing beaches because that was my first question. What is a fishing beach? So a fishing beach is basically a beach that has either a pier or some kind of structure where people can fish near the beach. So we know of a lot of those in Lake Michigan. So those were the fishing beaches, and then the non-fishing beaches were those that were away from, piers and structures. And in terms of percentage of debris, it was about neck and neck, about 80% or over 80% was combined food-related and smoking-related. So he also looked at specifically in terms of the categories themselves, looking at the fishing beaches and non-fishing beaches in relation to the different categories, food-related, smoking-related, the fishing-related, and what's contained in the red would be what would be coming from fishing-related. And most of our activities in the Great Lakes in terms of fishing are more recreational, where maybe in the oceans they tend to be more commercial. So again, there's some variation there, but it's not statistically significant. So really the answer to the question is there really is no significance between fishing beaches and non-fishing beaches in terms of the categories of items that they're finding. So the answer to the first question was no. Fishing does not really impact in terms of the majority of looking at overall the beaches in Lake Michigan. So fishing does not contribute to the litter. So the second question they wanted to ask, and all across Lake Michigan, does river proximity to the beaches impact the amount of the density and the composition of the litter? They assumed there would be more litter. That makes sense, closer to river mouths based on ocean communities. So this is what they found. This is the distance. We're going left to right, closest to the river mouth, and then to the right is farther away from the river mouth. And there looks to be a curve of proximity, but in terms of statistical relevance, there really isn't much difference. So the conclusion in terms of the abundance was there's no significant difference in terms of the proximity to the river mouth. And this is by category. So we also looked at it by category, looking at food-related activities, smoking-related activities, the waterway activities. And again, you can see some variation, but it really isn't statistically significant. So, and one other thing they did is they looked at in terms of percentages. Now, just looking at the percentage of the categories, again, it's almost across the board. If in terms of distance from beaches that are closest to the river mouths to the farthest away, there almost is no difference in terms of the categories. We're still looking at like 80% across the board in terms of, or over 80%, that is smoking related and food related. So the question to the second, or the answer to the question, the second question about proximity of rivers to to the beaches in terms of litter density and composition is that no, it doesn't have an impact. Now, Tim and I talked about this just the other day because there is some variation within that, and one of the things that we have been talking about, or I've been talking with some of the researchers, is that with big storm events, we tend to have a lot of stuff that comes out of the rivers and channels that are ending up in the beaches, but it's different than what we normally find on the beaches. It's including other small pieces of litter that is not as typical, a lot more woody debris, and also just pieces of things. And this has been happening along West Michigan this year. So that's one of the things that can be different, but for the most part overall, there is not a difference, but there are some variations. The other thing they looked at was in terms of population density. This makes a lot of sense. If you have a higher population, you're going to have more litter. And so these are the original 5 beaches on the left. And so that's just looking at everything as a whole. You can see there's a variation here on the left. And Tim and I talked about this too. This is in Allegan County. It's called Westside County Park. It is in Allegan County, Michigan. There is not a lot of public access in this area to beaches or to Lake Michigan. And so this is a fairly large park. So a lot of people are coming to this park, so they're tunneling in to be a part of this park. So we think that might be the reason there's variation, because there's not a lot of public access in this area, and this is it. And this is a really nice, fairly large park. The one on the left is just showing, again, there's more data that he put together with the 200 beaches. And you can see that, again, there is a curve, but there is some variation. So why count litter on beaches? So we've answered a couple questions. So basically, the biggest sources to our beaches are things that we bring there and leave behind, smoking-related things and food-related items. And population density does impact the amount of debris. So these are all important questions because they've not been really answered before in the Great Lakes. I mean, we've had the litter data, but it's not been analyzed and compared to other ocean communities or other areas. And again, keep in mind, this is Lake Michigan beaches. The other question that we were able to answer was in terms of fishing and river proximity, is that fishing does not have a large impact on the amount of fishing-related material on beaches, whether it's a fishing beach or a non-fishing beach, and that river proximity does not have, for the most part, a big impact, except for these particular incidences that occur from time to time with heavy rains or heavy storms. So the other thing I wanted to mention was the other ongoing project that Loyola University will be doing with their students. And so this is going to be specific to one beach in Chicago, Pratt Beach. And the reason why they've decided to go with a very specific beach using the researchers is there's a lot of really good things about the Adopt a Beach program and the way that we've been doing the litter collection. There is lots and lots of data. This goes back to 1991, and we have it all stored from about 2003 into a system that's similar. And then there's multiple sites, multiple dates. The problem with the data, or I wouldn't say it's a problem, but the thing that makes it so variable is the inconsistency in terms of the number of the volunteers in the area of the beach. So, I mean, we may have 5 volunteers on a great big beach that can only pick up, you know, a very small portion of the beach, or we may have 100. I mean, a lot of that's been taken into consideration, but more needs to be done, and we're looking at some of the things that we can do to fix parts of this too. But so that's why they decided to go with a more intense study using university students at Pratt Beach, where they're going to divide the beach into transects, and then they're going to pick up everything. So they'll be sure to pick up everything, where our volunteers may not pick up everything because they're only there for 2 hours. So they'll make sure they pick up everything. Places like along the pier, is it more accumulating? They'll also see the rate of accumulation at the beaches. And they've already done this all summer long, or last summer, and so that's what they're doing. Right now they're looking at that data specific. So we're learning things about the sources and the fate of data, or the fate of the litter as a result. So proximity, or prioritize sites for cleanups and efforts. So that's one of the things we want to do. More frequent cleanups, better delineation of beach areas. There are certain things that we're looking at in terms of source and fate. And also learning more about the Adopt a Beach data itself in relation to a more in-depth project. And the whole point here is to develop solutions. And so there is a lot of work going on right now in the Great Lakes to talk about this. We're starting to talk about this. Some things will be probably implemented or tested out in the next year. And then the next steps overall is to actually apply more of information or data or analysis to the Adopt a Beach program data. And that's something Loyola is doing. Like I said, it's only Lake Michigan. And then there are some of those variances, so there's more to learn. As Loyola answers questions, then there seems to be more questions that they want to answer, and that's how the data goes. And so the other things that are missing are the microplastics, and we are actually changed our data card in the last year that looks at pieces of plastic, maybe not microplastics, but what's the tie-in with microplastics. I heard just the other day about sediment sampling, some of that's happening. And then looking at annual rate of accumulation, and then thinking about how does municipal beach cleaning impact that, and starting to look at decomposition rates in freshwater, and even, you know, where things fall in the water column in terms of, you know, how they float or sink. So that's kind of a wrap-up of what's going on in Loyola. Lots more to come. Like I said, tomorrow's panel should be very interesting, too, to hear from some of the great work that's been going on. So thank you.
So we have some time for questions. Are there any questions? Go ahead.
Jamie, as you well know, it's 10% bottom deposit in Michigan. I'm not sure what it is in the other states around Lake Michigan. Have you seen any differences in
Let me repeat the question for the people on the webinar. So the question has to do about bottle deposits and whether having a bottle deposit system like Michigan has, is there a difference in what you see on the beach?
What I'll say is that we have some groups, Friends of Sleeping Bear Dunes, that have in the last couple of years separated bottles that are for deposit and non-deposit. Especially because water bottles don't have it, and we've increased the amount of water that we drink. And so they're seeing that for glass bottles, at least at Sleeping Bear Dunes, whether they have a deposit or not, there's not much of a difference. But for the plastic, there is a huge difference, and I can't remember the percent. It might be 75% more are non-deposit as those with the deposit on it.
Good question. Any other questions?
Yeah. You mentioned something about decomposition of litter. So how do you do it?
How do you do decomposition of?
That will probably be done in a lab and way beyond my expertise, and probably something to ask the researchers tomorrow.
You had a question?
wondering if your medical background if you see any difference in cigarette related
We have tried to look at that.
Do you see a difference in smoking litter since smoking?
Smoking was made illegal a few years ago.
So it was made illegal at the beaches in Chicago. Are you seeing a difference in the litter?
Kathy, I've really tried to look at that, and because of the variation, it's really hard to determine. I do know that we are working with Loyola to apply for something. Maybe you know about it. It's a campaign we're going to try to do in Chicago at a specific location to see if we can make some differences and do some counting.
Okay. We have time for one more question.
Well, I think
way in the back.
Yes, that's the question.
Fireworks debris, have you dealt with that or have any success stories?
He's asking about firework debris and success stories. I will say that we started counting the firework debris. I don't know how many years ago, because we were seeing it increase and people were noting it. And the only thing I can tell you about that is it got added to the International Coastal Cleanup part because we noted that it was an impact. So it's a good question and one we haven't quite got to yet.
Okay. Thank you very much, Jamie.
Thank you.
Our next speaker is Laura Vogel. She's a PhD candidate from University of Western Ontario, and she is going to talk about methods to sample E. coli in the Foreshore and Pore water.
Hello, everybody in present and on the computer. As she said, my name is Laura Vogel, and I'm from the University of Western Ontario. And today I'm going to talk to you about a very important subject that's just coming up recently. And I'm going to talk about methods to sample E. coli in the Foreshore sand and pore water reservoir. So quick introduction. As many of you know, E. coli is often orders of magnitude higher in the sand and pore water near the shoreline than in the shallow lake waters. And this reservoir can act as a non-point source for contaminating lake water. And I know many of the studies that some of you here have done have collected samples from the sand and pore water and quantified that. However, the health units that go out and sample, they do not currently sample any of the sand and pore water near the shoreline. So recently, this year, a paper came out, and I know some of you in the audience are actually co-authors on this paper, so shout out to you guys. And this paper suggested that sampling for microorganisms in the sand should be considered for inclusion in regulatory programs aimed at protecting recreational beach users from infectious diseases. So this is a very important topic. And if we're going to be able to do that, we're going to have to provide some sort of information on how to collect these samples. We can't just say, hey, go out and collect them. We have to tell you how. So that's where my work comes in. So currently in research studies, there are a few methods of sampling collection for the sand and the pore water. Some studies sample the unsaturated foreshore sand near the lake interface. Some samples dig down to below the water table and they sample the saturated foreshore sand. And other studies actually sample the pore water in between the sand and the saturated sand. So what we plan to do, this project, is we want to know how we can quantify the foreshore reservoir. So is one of these methods the best, or are all of these methods the best? And lastly, we want to know if we can compare these different sampling methods between studies. Because in addition to having just these sampling methods, each one of these methods has different methods. So you can go out and you can collect sand, foreshore, there's saturated foreshore sand, but you can also do that in many different ways. So that's the purpose of this study. So the objective of what I'm going to talk to you today is we want to determine the impact of sampling methods on the quantification of E. coli in that foreshore reservoir near the lake water interface. So the first question I'm going to answer is, do E. coli concentrations vary with sampling method? And to answer this, I'm going to group together a bunch of beaches that we looked at, and considering all of the beaches together, do the concentrations vary? In addition, I'm going to look at individual beaches. So beaches with different grain size, sediment type, and all of those, and see if the methods vary at those sites. The second question I'm going to answer is, which sampling methods are the least variable? And for some people, you might want to know, well, why does she care about that? But once we determine a method that's going to be best, we want to find one that's the least variable. We want it to be able to tell us what exactly is in the reservoir with the least variability possible. So you can take less samples, which saves you money. So the study sites we selected, as I said, I'm from Ontario, so I'm part of the Great Lakes, but not the U.S. side. This here is Lake Huron. So we have one beach on Lake Huron called Ipperwash Beach. And then here is I'm sure many of you know where Toronto is. So this is kind of the stretch where Toronto is. And we have 5 beaches along, and this is Lake Ontario. So we have Bayfront Park Beach in Hamilton, Burlington Beach in Burlington, Bronte Beach in Oakville, Marie Curtis Beach in Etobicoke, and Sunnyside Beach in Toronto. And these beaches range from many physical parameters. So the first physical parameter is sand grain size. So you can see Marie Curtis and Bayfront Beach, these two are both really close to Toronto. And these are very coarse sand grain beaches. And our grain size ranges from about 1.3 to about 0.15. The next 2 beaches are medium sand, and the last 2 are the fine sand grain beaches. And we really wanted to make sure we covered the spectrum, because if we recommend one method, then it might not apply for all the different types of grain sizes. So next we looked at the moisture content for the unsaturated sand at these beaches. And you can see that the moisture content was inversely related with the grain size. So the coarse sand grain beaches had a smaller moisture content than the medium and the fine sand grain beaches. And lastly, we looked at organic content %. And what was interesting about organic content, well, it ranged from about 35% to 0. And what's interesting is if you look, see if I can use it. Yep. I doubt the people on the screen can see, but I'm pointing to the Burlington and Ipperwash bars that are very low. And these two beaches were the only beaches that weren't impacted by birds, heavily impacted by birds. So it's interesting to note that those were the beaches that had very little organic content. Okay, so this is just to remind you what the current sampling methods were. We're looking at unsaturated sand, saturated sand, and pore water, all by the foreshore area. So I'm going to discuss the different methods that we used. To collect surface water, I'm sure many of you know, you wade out into the water and you can sample either from ankle depth all the way out to chest depth, and it varies between different states and different provinces. So to sample the pore water, we use 3 different methods. One we call the shovel method, which has been used in many studies, and it's where you go from about 1 meter from the shoreline, so the waves cannot rush into your hole, and you dig until you hit the water table, and then you take the water sample with a bottle. And with this method, you have sand that's falling in, and it's not very accurate to just characterize the pore water. That was at least what we thought, and I'll show you the results in a bit. The second method we kind of made up on our own, which is called careful excavation, and that was trying to be similar to the shovel method, but allow less sand to fall back into the hole and to actually get the top of the water table. Because with the shovel method, you dig further down, so you're getting a big mixture of pore water, where we wanted to see the top of the pore water where most of the E. coli is known to exist. So then with that, we used a syringe just to suck up the top of the pore water. And the last method that we used was drive point. And this is a pole with a tip I'll show you at the end. And with this, we pump up water from the ground, so that disturbs the sand the least, and we can just get a water sample. And to note, that size of the screen there was large enough for E. coli to pass through, so we didn't have any straining effects. So now we talk about the methods of sampling unsaturated sand. At first, when I started this study, I was aware that there was only one method, and everybody did the same thing. However, I talked to Tom Edge, which I'm sure most of you guys know. He's like, no, Laura, there's many different types to calculate or to sample unsaturated sand. So I added another one here. So with these two methods, I used either a shovel or a small PVC pipe and sampled just the top 1 centimeter of unsaturated sand. Whereas the other method here, I used a core and I went down 5 centimeters and took about 5 centimeters. And for each sample, I took a few going around the hole to get a good representative of that area. So lastly, the saturated sand. We use the same method as the shovel for the water, except instead of taking the water, you take the saturated sand that's underneath that pore water. For careful excavation, again, it's the same thing, but once you take the water first, then you go and you take the sand. And it's important to note you always take the water sample first, because once you're taking the sand, you're going to disturb all of that E. coli in the sand, and you can release it into the pore water. And lastly, we did a core sample where we took the top. We found the water table by digging a hole, and we took 5 centimeters above and below the water table. So the first question we want to answer is, do E. coli concentrations vary with sampling method? And this is when I considered data for just the individual beaches themselves. So here, since the data was very variable, it wasn't normal. Even when you log transform it, it's hard to normalize with the small data sets. So I did a ranking method, which is used in non-parametric statistics. So I basically ranked the beaches. So I said, okay, at Bayfront Beach, was shovel the method that showed the highest concentration of E. coli, or was it careful excavation? And I ranked it 1, 2, 3, with 1 being the highest concentration and 3 being the lowest concentration. So you can see there's somewhat of a pattern here where Drive Point had the lowest concentration in each of these except for this one site here at Bayfront Park. So you can see that's sort of a pattern where Drive Point had the lowest concentrations except for the one beach. However, if you look at the error bars, it's not statistically significant. So there's not a lot that we can say about it except that we do see somewhat of a pattern. When we look at the saturated sand methods, you get a different story and it's all over the place. And one of our reasons for thinking that this is when we're taking the samples in the same location, we say it's the same location, but you can't necessarily do that. It's going to be about 10, 20 centimeters apart. So even though we think it's the same location, there's a lot of spatial variability in there. So it's going to be hard to get the same sample every time. So from here, we didn't really get any significant results. And that's kind of where we got the idea of combining all of the beaches together, which is coming up in a bit. But next, this is pretty interesting. So we wanted to look at the distribution of E. coli between the sand and the pore water and how the distribution changed when we used different sampling methods. To do this, we standardized all the concentrations by volume, so everything was converted to CFU per centimeter cubed. And when we did this, we found the percentage of E. coli that was in either the water or the sand for each method. And we saw generally that shovel had the highest concentration or the highest percentage of E. coli in the pore water, followed by careful, followed by dry point. And if you think about how these methods were taken, it makes a lot of sense. As I was saying, when you take the shovel method, you're mixing up all the sand, there's sand falling in the hole, there's a lot of E. coli being released from the sand and into the pore water. So you're going to see higher amounts in the pore water, and you're going to see lower amounts in the sand. Careful is kind of our middle case. And lastly, drive point. When you do the drive point, you're barely touching the sand. Well, you're touching the sand, but you're not necessarily releasing E. coli from it. You're not disturbing it. And that's why we see that as the lowest case, the lowest amount in the pore water and the highest amount in the sand. Yep, there's that conclusion. So the next question we were looking at is the same question, do E. coli concentrations vary with sampling method, but when we combine all of the beaches together? So for pore water, we did some statistics, and here we have the shovel, careful excavation, and drive point methods, and the medians, and then we did some analysis to see, we found the p-values, to see if any were significantly higher than the others. And from this, we saw that the shovel and careful excavation methods resulted in higher pore water concentrations than the dry point. And again, that goes back to the previous slides, that you're getting more E. coli mixed up from the sand into the pore water. So it does make sense that the dry point has the lowest concentrations. But why would we care about that? And that depends on what you're looking for. If you're out there and you want to find out what's in the pore water and you're digging a hole, you might not necessarily be getting what's in the pore water. You're getting what's in the sand that's released into the pore water. So if you wanted to know what was in the pore water, you may want to take the dry point sampling. And again, here are the different methods that we use. These two are shovel and careful, and then we have dry point. So when we wanted to compare the unsaturated sand, so the top 1 centimeter versus the top 5 centimeters. And when we did this, we found that the unsaturated sand, the top 1 centimeter, had statistically higher concentrations than the top 5 centimeters, which is what our hypothesis is, that most of the E. coli is in the very top of the unsaturated sand. But additionally, we also saw that the top 1 centimeter had statistically more variable concentrations than the top 5 centimeters, which is interesting because you're getting a lesser of a volume, but you're getting more variability. So then we compared all of the beaches and the methods for saturated sand. And when we did this, we didn't see any significant difference between the saturated sand collection methods. So using the methods that we use to collect saturated sand were statistically no different from one another. However, and here are the different methods here. However, when we added unsaturated sand, we saw that unsaturated sand was significantly higher than all of the saturated sand methods, which is very interesting. The last question is we wanted to know which component of the reservoir is least variable for sampling. And again, this is important because that'll be very useful for coming up with a standard method of sampling. So when we looked at the variability in the sand, we saw that unsaturated and saturated sand, there was no statistical difference between the variability of the two. You can see that unsaturated sand does look more variable, but not statistically significantly more variable. However, when you look at the unsaturated and saturated sand versus the pore water, you do see a significant difference. So we see that pore water is statistically more variable or statistically less variable than the sand, which might be very important because maybe if we went and tried to characterize the reservoir by sampling pore water, you'd have to take less samples than if you were measuring using the sand. So in conclusion, when we looked at the data for the individual beaches, we didn't see statistical differences between E. coli concentrations when comparing the sampling methods. And this may be able to fix if next summer we go out and take 100 more samples per beach. The sampling method used affects the amount of E. coli released from the sand into the pore water. And when we considered data for all of the beaches combined, we found that sampling the pore water using a drive point results in the lowest observed concentrations than using the shovel or careful excavation method. We also saw the unsaturated sand had higher concentrations than saturated sand, and the top 1 centimeter of unsaturated sand had higher concentrations and was more variable than the top 5 centimeters of sand. And lastly, we saw that E. coli concentrations in the sand are more variable than in the pore water. I'd like to thank these following organizations for helping me. I would also like to thank my advisor watching from Switzerland, thank you, and my parents watching from Miami. Hi, Mom.
Thank you very much. We have time for one question. Who's got the most pressing question?
It's got to be good.
Laura, what was the potential impact of a regular beach grooming program when you're actively raking, disking beaches? It sounds like E. coli is in the top layer. Regular program could probably drive that down deeper. I'm not sure. Was there a regular program at your beaches that you studied?
So the question is there regular beach grooming, and how might that affect the concentrations in the top 1 centimeter where you saw it highest?
Okay. Well, some of our beaches that were in smaller areas, they didn't have a grooming program. I'm sure Julie knows all about beach grooming. But the ones that we did notice as we sample, we see hot spots of E. coli. And we think the grooming might be mixing up these hot spots and spreading the E. coli. I'm not sure about depth because I'm not sure how thick the rakes are, but I know it might be spreading these hot spots around the beach.
Wasn't sure if the active raking and movement of the sand with exposure to the elements would perhaps kill the E. coli.
Mm-hmm.
So does exposure kill the E. coli, basically?
Yeah, I don't have much experience in that, but I think, if you wanted to mention.
Is anybody from here, from Julie's lab or Wisconsin? Where's Kim? You want to comment on that real quick?
Sure.
We make it quick.
No, we've got a minute. You got a minute.
Oh, okay. From our experience, when we would monitor, we were monitoring Burch for sand, but I know Julie's done a lot of studies with grooming her beach using different mechanisms, and if she's grooming deeper, the direction of the grooming, and we noticed that does make a difference. When we purchased our groomer through the Great Lakes Restoration, it came with like a rubber mat that will smooth out the sand, and we did some sampling looking at when the sand was smoothed over, we had higher E. coli concentrations versus when we actually took that off and left the grooves in the sand. So we did notice a difference there, but
So Racine is seeing some difference, and smoothing the sand actually doesn't help you. So, thank you very much. Great presentation. Our next presentation is QPCR, a rapid method to monitor water quality at a national park, and our speaker is Don Shively from USGS.
Okay, perfect. Okay. No. Oops. We're hunting it down. Oh. Is it? Oh,
Yep, there we go.
No, that's not gonna do there.
Oh dear.
All right, we might jump to the next speaker because we need to go find her talk.
I
have it on a pen drive. You want to do it again? Because he just loaded it. Where do you? Yeah, I don't know. Let me get you my pen.
Tucker, do you want to come
Sure.
and do yours,
Yeah.
and we'll get the thumb drive and. All right, so quick change.
Yeah, for the webinar, we're just going to switch to speakers.
Tucker Burch is a research hydrogeologist at the USGS, and he is going to be talking about quantitative microbial risk assessment for recreational waters at 3 Lake Michigan beaches.
Okay, thank you. I'm curious, I gotta ask before I get started, how many of you have heard of quantitative microbial risk assessment? Raise your hand. Awesome, that will make things easier. So there's other QMRAs out there that deal with recreational water quality, and a lot of these are kind of at a high level, kind of broad. And I think what's unique about this work is that it deals with how QMRA can be applied in a site-specific way and in a way that allows for the forecasting of risk. So here's the situation we're dealing with. You and your family are at your favorite beach. My favorite beach is not far from here. If you go up across the bridge and go about 5 or 10 miles west on Highway 2, I love that beach. It's like one of my favorites to go swimming at. When you're at the beach, there's a lot of potential point and non-point sources of pathogens from fecal material. These can be, wastewater treatment outfalls. They can come from wildlife in Wisconsin and other places. We have a lot that comes from agriculture. And the basic question is, when you're enjoying the beach, what is the health risk? So why would we use QMRA to answer this question? This is kind of a broad level of what QMRA does. If we start on the left and we think about human activities and environmental conditions controlling the abundance and distribution of pathogens in the environment, the thing that QMRA does is what's on the right-hand side there is it lets you estimate health risk. If you can complete that cycle, that allows natural resource managers and policymakers to alter human activities or alter environmental conditions to reduce risk. If you can't estimate health risk, you're not totally sunk. I mean, you can still work from pathogen data, but QMRA basically it gives you like a nice way to interpret the data. This is QMRA in a nutshell. Every QMRA consists of 2 basic components, which are the yellow and the green there, the first 2. The first is the exposure assessment, and the whole idea here is we're just trying to figure out what dose of pathogens you might be exposed to. You need to be able to get the pathogen concentration, in this case in the water, and you also need to be able to get an estimate of how much water someone would ingest during an exposure event. The ingestion volume is actually not too difficult. There's a lot of data in the literature that you can use to get at that. It's probably also should be, yeah it is, in the EPA Exposure Factors Handbook. The pathogen concentration, there's a little bit more of an art to deciding how you're going to do that because there's a couple different ways to approach that problem. You can take direct pathogen measurements and just work straight off of those empirical data. You could take direct pathogen measurements and then develop empirical models, which is the approach that we took here. So to predict pathogen concentration based on, for instance, water temperature or cloud cover. You could also develop a model that's based on a mass balance or some other first principles to predict pathogen concentration. But once you put that together, the concentration and the ingestion volume, you've now completed the exposure assessment. The next piece is the dose response assessment. And a lot of this comes from feeding studies that were done long ago when it was still possible to do feeding studies with human volunteers, where you would give the volunteers different doses, and then you would have some operational definition of the response. It might be an operational definition of illness or infection. So for instance, I'm going to make this up on the spot, so don't. It might be fever, vomiting, or nausea within 24 hours or something like that. You can develop dose response curves based on those data that tend to look kind of like this little fictitious example here. They're sigmoidal. With QMRA, the dose response, well, the other way I should say too to get dose response data is you can also, the data is not always available, but you can also work off of outbreak data. There are some health departments in the United States and in other countries that when their outbreaks happen, collect enough data that you could actually develop dose response curves. In any QMRA, the dose response assessment is usually going to come from the literature, and the exposure assessment is going to be unique to whatever the specific problem is that you're dealing with. When you put those together, you can estimate risk, which is a step there on the last step on the right. I've got Monte Carlo in parentheses there. You don't have to do a Monte Carlo simulation to be doing QMRA, but it's very common because there's a lot of variability and a lot of uncertainty that goes into a QMRA, and people like to use Monte Carlo simulations as a way to essentially qualify the results, to put error bars on the risk estimates. So these are the questions we're interested in asking or answering. The first is, what's the risk relative to the recreational water quality criteria? So you'll see later we're going to actually very explicitly compare our risk estimates to the 32 illnesses per 1,000 recreators per swimming event criteria. The second question is, what factors can be potentially manipulated to mitigate risk? So are there some, one variable or some set of variables that together could be a criteria where you might make a beach management decision to close a beach or to have an advisory? And then also, what do we need to know to more fully characterize the risk? The approach we took is pretty straightforward. It's just 3 steps. The first is we quantified the pathogens at the beaches that we're interested in. The second is we use those data to develop empirical models as functions of environmental predictors. And the third is you use those models to estimate risk, to do the exposure assessment and then conduct the QMRA. So it's just data, model, estimate risk based on the model. These are the watersheds and beaches we're dealing with. So this is 3 beaches on the Wisconsin side of Lake Michigan. There's a mixture of land use types, so there's some agricultural influence, there's some urban influence, and there's also some natural areas. I will say, actually, my second favorite beach is Point Beach. My wife and I went camping there this summer. It's kind of a long beach, and if you're willing to hike a little bit, you can get like a big chunk of beach all to yourself just to hang out on all day. For methods, for sampling, we sampled for an entire swimming season from Memorial Day to Labor Day in 2010, about 20 times at each beach, maybe a little more than 20. We ended up with about 70 samples total. We use glass bowl filtration. One of the important characteristics of this is it lets us take really large water samples so we can really push our detection limits down quite a bit. The analyses, we analyzed for 21 human, bovine, and zoonotic pathogens using QPCR. You'll see for the QMRA, we selected the most prevalent human or zoonotic pathogens. So we just used 3 pathogens in the QMRA, but we initially screened for 21. We also did culture work for 2 bacterial pathogens because one of the random things you have to deal with in QMRA is many of the dose response curves are based on culture data, not QPCR data. The pathogen modeling was done using Tobit regression, also known as censored regression, and the main feature here is it lets us deal with the large number of non-detects that we get in our data because you're not going to find quantifiable pathogens in every single sample. And we initially screened over 200 candidate predictors for each of the pathogens that's in the QMRA. You'll see you end up with an incredibly smaller amount of actual predictors when you're done. In fact, one of the pathogens, basically nothing could predict its concentrations that we screened at least. So I'll start by showing you the pathogen data itself. So what you're looking at here is for the 3 most prevalent pathogens based on how often we found them in the samples. And these were enteroviruses, Campylobacter jejuni, and Salmonella. These are the range of concentrations that we found. So the points are the median concentration, and the whiskers are the 1st and 3rd quartiles, 25th and 75th percentiles. The percentages at the bottom of the plot there tell you how often we found them in samples. So some of these we found in samples quite often. For instance, at Point Beach, Campylobacter jejuni was in 88% of the samples. That's, in my opinion at least, that's a reasonably high number to find it in 88% of the samples that we measure. And the problem here, and this is kind of what QMRA helps us with a little bit, is even though we find it frequently in these samples, is it bad in terms of human health? So how do we interpret the median concentration of 40 and these are genome copies per liter. You can think of them very crudely as cells per liter. So we took those data and modeled them like I talked about before, and this is kind of the summary of the modeling results. For enteroviruses, there were 4 predictors, parallel current, 2 different pieces of the wave component, so which direction the waves are moving relative to the shore, and also 10-day water temperature. For C. jejuni, we had 2 predictors. One is cloud cover, the other is beach, and it really means point beach. And this predictor makes sense if you remember the plot. The Campylobacter jejuni concentrations were all noticeably higher at Point Beach than they were at the other 2 beaches. For Salmonella, there are no predictors out of the 200 that we screened that could predict the concentrations well. So for QMRA, for Salmonella, it's an incredibly simple QMRA. We basically just went straight off the data. There was no model to simulate. So here's our method slide again. I kind of already said this, for enterovirus and C. jejuni, we use the models that we developed to simulate concentration. Salmonella comes off the raw data, and the ingestion rates and swim times are derived from the literature from Supis et al. 2014. For the dose response assessment, we used an echovirus dose response curve for enteroviruses. For C. jejuni, we used a feeding study-based dose response curve. For Salmonella, we used an outbreak-based dose response curve. We want to use outbreak-based curves whenever we can because 2 things. They probably represent the strains of pathogens that are circulating out in the environment more closely than the feeding study-based curves, because the feeding studies are often done with lab-adapted strains that are not as pathogenic. And the outbreak-based curves also probably reflect a general human population better than the feeding study-based curves. The feeding studies are usually adult, healthy volunteers, which obviously it's not a general population. For the risk estimates, we use the Monte Carlo simulation. We used an approach called 2-dimensional Monte Carlo simulation. And the basic idea here is that you're doing Monte Carlo simulations within Monte Carlo simulations. So you have one level where you simulate things that are variable, and that means things out in nature that would actually change. So in this case, things like cloud cover and water temperature and the wave components. At a higher level up, you're simulating variability in the model parameters. So we call that uncertainty. And that would be like the coefficients of the regression models and the parameters of the dose response models. The advantage is that it lets you address both variability and uncertainty, but separately. So you can look at just the variable component, which is what people are usually most interested in. As the person doing the QMRA, I'm interested in the uncertainty part of it, but a lot of other people are not going to be. Just to give an example and to kind of, I guess, try to emphasize that we simulated these things using distributions as much as possible. These are the inputs for the Salmonella QMRA. So these are the distributions of the inputs that we use. So in the top left, we've got the concentration, that's CFU per liter of the Salmonella. Then we have ingestion rate and swimming time. Ingestion rate and swimming time and concentration would be regarded as variable inputs. The other 4 are just parameters of a dose response model. You can imagine it gets much more complicated when you have more inputs, so that was the most simple version. Here are the actual risk estimates. You're looking at cumulative distribution functions. So for instance, you can go up to the 50% line on each of these and move over to the solid line, and that tells you what the median risk is. And that solid line is median risk in the variability dimension. Those dotted lines come from the uncertainty dimension, so those are kind of our error bars on the risk estimates. Let's see here. I've got the medians indicated at the top. What you can see is that all 3 medians are below the recreational water quality criteria, which is indicated by that vertical dashed line. For enteroviruses, none of the risk estimates exceed 32 illnesses per 1,000 recreators. For C. jejuni, it's like less than 1%. For Salmonella, it's about 6%. So this is kind of a subtle thing here. Even though Campylobacter has the highest median risk, Salmonella most frequently exceeds the recreational water quality criteria, and it's because that Salmonella risk distribution is so wide, it's so variable. And then these tornado plots basically show the influence of the different inputs into the QMRA. So what we're looking at here are those inputs that were regarded as variable, and then these are their correlations with the risk estimates. And then obviously the things at the top are most correlated with the risk estimates, and the things at the bottom are least correlated. And if you're looking for interventions or mitigation measures, and you have a plot like this, what you basically want to do is start at the top and say, can we influence this somehow through management decision or policy decision? So back to our questions. What's the risk? The median risk in all cases is less than the recreational water quality criteria for all 3 pathogens. It does get exceeded occasionally, and for instance, for Salmonella, about 6% of the time. So what that tells you is, this is maybe a slightly fictitious part of this example of QMRA, you probably wouldn't be managing, I don't think, all 3 of these beaches simultaneously, but if you were, this would tell you, okay, the pathogen we should be most interested in is Salmonella. What can we do to figure out where the Salmonella are coming from and mitigate that source? As far as factors that can be manipulated, if you're just looking for one, there's really not a lot here for enteroviruses and C. jejuni because the most influential thing is ingestion rate. You obviously can't control how much water people swallow when they're swimming. But you might be able to look for a set of multiple criteria in those tornado plots to be able to control. For Salmonella, again, it's concentration that controls it. So you would want to find where the Salmonella are coming from, essentially. And that leads into what do we need to know to more fully characterize risk. It'd be the sources of Salmonella at these beaches. And then also, I didn't hit on this at all, but the Salmonella serotypes. There's like over 2,000 Salmonella serotypes. They vary a lot in how likely it is that they would make you sick. This QMRA does not account for that, so that's a source of kind of unquantified uncertainty in this QMRA. And for end, I just want to thank Colleen and Greg and Austin Baldwin. They did all the sampling, and I think also Colleen and Greg's students did all the sampling that this QMRA is based on. And then also I'd like to thank the funding sources, the GLRI and the Ocean Research Priorities Plan. Thank you.
So, and we'll try for one question. Does anybody have a question? Go ahead.
So, Tucker, I noticed in your plots that you presented of the concentration presented as CFU or gene copies per liter. Then in the risk model, it would be CFU per liter.
Right.
How did you develop that correlation between gene copies per liter and CFU?
Yeah, there's a.
So,
oh, sorry.
would you repeat the question?
Sure. The question was the data that I presented for concentration were genome copies per liter, and then the QMRA uses CFU per liter. And the question was, how did we get from the one set of units to the other? For Salmonella, we just went back and measured it directly. For Campylobacter, because we already had the model for the genome copies, we needed to be able to get from those predictions to CFU. And so there's actually, buried in there, but there's an extra regression model in between that goes from genome copies to CFU.
Okay, thank you very much.
Thank you.
All right, Dawn, we'll try once again.
Yes, we got it.
Yes, we're going to talk about, she's going to talk about QPCR, a rapid method to monitor water quality at a national park.
Can you also ask, we've got a lot of people sitting, can you raise them, how to say it? If you have an empty seat next to you, can you raise your hand? This is your big networking opportunity to make 5 new connections. So if you're standing in the back and you want to sit down, we got 2 up front. We got some over there. If you want to sit next to Michelle, she smells really nice. So yes, come on in, find a seat. I think that's the one, right?
Don't be shy.
All right, here's your clicker. And it works best to stand behind the microphone. Make sure you're like here. You can stand there. Just make sure you don't look at your slides and talk.
Okay. Hi, I'm Dawn Shively, and I'm with the USGS, and we looked at QPCR at Sleeping Bear Dunes National Lakeshore. Okay, what did I do? Okay. So I have to say that Sleeping Bear Dunes National Lake Shore has some of the most beautiful beaches, and I highly recommend that you check them out if you haven't gotten an opportunity. So Sleeping Bear Dunes uses E. coli culture-based method to monitor the beaches for water quality. And we know this whole lag time between sample collection and test results. So beach managers have been looking for a more rapid method to determine their water quality. And QPCR is one of those methods. And for those of you that don't know what QPCR is, it's similar to PCR in that it measures DNA of a target organism. In our case, it's enterococci. The difference is that it measures it at a real-time basis and it's quantitative, so you get an actual number for your sample. Sleeping Bear Dunes is the first national park in the Midwest to evaluate QPCR at their beaches. So in the summer of 2014, USGS and the National Park Service, Sleeping Bear Dunes, did this study on evaluating QPCR at some of their select beaches. And we looked at QPCR performance versus the culture-based method for enterococci. So the study area, again, Sleeping Bear Dunes National Lake Shore, we looked at 2 beaches and 2 of their river outfalls. And these outfalls are also designated as recreational areas. The sites were Platte Point Bay and Platte River and Esch Road and Otter Creek, and there were 3 sampling sites at each location. And the methods, we sampled, well, the park sampled over a 7-week period in the summer of 2014. And since it's kind of important when you're adopting a new method to understand what the variability is in your sampling. So we did some intensive sampling as well at Otter Creek and Esch Road. And this took place over a few select days. And we collected 5 replicate samples during this time. All samples were measured for culturable E. coli, enterococci, and they're through membrane filtration, and they're expressed as CFUs. They're also analyzed for QPCR, enterococci, and those values are expressed as CCEs. So the results. Here you can see that CCE was significantly higher than CFU at all locations except Esch Road. And this makes a lot of sense since QPCR measures both live and dead cells. And we've also seen this in some of our other studies where the CCE is significantly higher than CFUs. Otter Creek CFU and CCE were significantly higher than other locations. And Esch Road was lower, although not significantly. We also found that there might be some river influence to the beaches because Otter Creek CCE and CFUs were both significantly higher than at Esch Road, and they were correlated. Otter Creek CFU was correlated with Esch Road. And similarly at Platte River, CFUs were significantly higher than at Platte Point Bay, and the Platte River and Platte Point Bay CFUs were correlated. There were no CCE correlations seen. Okay, we also saw that enterococci CFU and CCE were significantly correlated at all locations and individual sites except for Platte River. This indicated that enterococci QPCR was measuring the same thing as the culture-based method, but obviously rapidly. Exceedances. This is one of the important things for beach managers besides rapid methods. And this graph shows CCE and CFU over time. The horizontal lines represent the EPA standard. They were there. Oh, okay. Well, no, I had the beach action values. So the beach action value for CFUs is 70, and for QPCR it's 1,000. All the exceedances, as you can see, occurred at Otter Creek, and there were fewer exceedances when you were looking at enterococci through QPCR, 16% versus 3%. So again, with this intensive sampling, we wanted to look at the variability in the samples. And from the intensive sampling data, we did some power analysis, which tells you how many samples you would have to take in order to explain some variability in the samples. In this case, we looked at 80%, 70%, and 60%. And what we found was that CCE was more variable, especially at Esch Road, than CFU. EC-CFU is more variable than the ENT-CFU, sorry. And Esch Road was more variable than Otter Creek. Now, some of these results are not very significant, as you can see. So if you take out the middle of the road at 70%, you would see that at Esch Road, you would have to collect, for CFU, CCE, and EC-CFU, you would have to collect 2, 22, and 4 samples. At Otter Creek, you would have to collect 1, 4, and 2 samples in order to explain the 70% variability in your results. So, inhibition and non-detects. With QPCR, inhibition and non-detects are a reality. Non-detects are where you don't get a CT value. And it could be due to low ENT. And in fact, 71% of all the non-detects occurred when CFUs were below 20. And the remaining occurred when samples were, CFUs were between 21 and 54. So very low densities. For inhibition, we've seen a lot less when we started using environmental master mix. But still here we had 3% of unresolved inhibition. And again, the master mix kind of improved that, but it was unresolved and it still happens. So conclusions, that went really fast. Conclusions, enterococci, CFU, and CCE were correlated. The low ENT targets and inhibition could affect your sample, your QPCR results. Probably not a big deal from a management standpoint as far as the non-detects go. There were fewer water quality exceedances when looking at CCE versus CFU. And the take-home message is enterococci QPCR may be a viable alternative method for Sleeping Bear Dunes beaches. And I want to thank Kevin Scarrow and Dan Ray, and for sample collection, Alicia, Ashley, and Chelsea, and of course our funding through National Resources Preservation Program. Thank you. Oh, these are a few of our pictures from our fun training sessions. It was a blast, actually.
So Dawn was fast, and you
I
have
was.
a question.
I just have one question about how you are evaluating for inhibition.
Through.
How are you evaluating for inhibition?
Yes, through the SCITA.
Can you explain, please tell us what SCITA is?
It's salmon testes DNA. Yeah. Yeah, I'm sorry. We are five-fold dilution. Oh, and with the samples that were inhibited, we did rerun them at 25-fold dilution. So we do kind of rerun them until we can resolve it or not resolve it. And if we can't resolve it, we do eliminate the samples from our data sets. Yes.
Well, you indicated that the non-detects wasn't a significant issue for management, but you did also note differences in exceedances that were detected. Could you comment on the significance of those numbers?
Repeat the question.
I'm sorry, I don't even.
The significance of the differences in exceedances that were measured by the two techniques. Could you comment on how that?
Oh, I'm sorry. Yes. It's just, I'm sorry. He wanted to know the difference between the exceedances for CCE and CFU. It's just showing you that you would have fewer exceedances as far as CCE goes.
So from a management standpoint, and you're trying to alert the public to those exceedances, do you think that was a significant difference, or from a management perspective, or?
Well, I think it is. Any time you can lower your exceedances, I think it is, definitely. Did I answer your question? Okay. Okay.
But on those days when you weren't detecting exceedances through CCE, are those days when the beaches perhaps should have been?
So the question is, should the beach have been closed on days when you didn't detect exceedances?
According
with the CCE.
Typically, I think we normally see QPCR numbers higher, right? And culture methods and stuff.
Correct.
So it's interesting that you had fewer exceedances due to QPCR. I mean, what do you think about that?
Well, there were only a few exceedances, so the CCE values were mostly very low in these beaches, as their E. coli values usually are. And I'm not sure if I'm understanding.
The decision error with CCE, do you see that as a problem? Were we making a wrong decision to leave it open on those days when the counts were low?
Well, I didn't look at those errors at all, so I guess that's a good point, and we should obviously look into that a little bit. Okay.
Yeah, I mean, it's a simple explanation. The criteria for CCE is quite a bit higher than it is for culture. And I don't know. I mean, in terms of whether it's a mistake to be, in the case where it's above the criteria for QPCR and below the criteria for culture. I guess, both methods have been, have gone through the same, evaluation of, in terms of health effects. They don't always give you the same answer, but they've gone through that same process. So, I mean, I guess it becomes a judgment call in your case if you believe, that PCR or culture is more indicative of health than you can make that decision.
So what I heard from that for the folks online is that through the validation process, EPA established the higher criteria, and it is a function of the higher criteria. So it's been subjected to the same health assessments. So it's sort of, I guess, in the eye of the beholder.
Yeah.
I mean, I could make one further comment, actually, in the epidemiological studies that EPA did. There was actually a better health relationship was seen with culture, QPCR than culture. But again, those are, sort of a specific set of sites there. It may not apply to your site.
So the data that was used for the health assessment risk was a better correlation with the CCE when you underlie that development. So the stronger relationship is driving it. And if I'm misspeaking, please.
No, I think you captured it well.
Thank you.
And thank you, Rich. I was not understanding what they were actually asking. I'm sorry.
Are there other questions?
Donalea, we can have all the speakers come up because now we've
Please, yes.
So now we have a discussion wrap-up time. We build this in case the computer broke, but also do you have some time to just talk before we all leave this session with all these thoughts in our head. So if Laura and Jamie and the speakers would come up, or if you want to just stand up where you are, but we will need to speak into the webinar mic.
I guess I think it would be better for the webinar folks if you would come up. So now this is the festival of questions. We're missing a a speaker here. Okay. All right. Any questions for the speakers? Go ahead in the back.
So this is just kind of a generic question because we do QPCR in our lab also, and so we hear a lot and we see a lot on slides and presentations and posters that QPCR is a rapid method. And so my question to the speakers in the panel is, how fast did you get the results from your QPCR versus your membrane filtration?
So the generic question is, when with rapid method, what does that mean in the real world with getting results?
Well, for our study, we just collected the samples and analyzed. So we didn't do, like, we collect the samples and run the QPCR. But normally it would be between 4 and 6 hours. And it depends on what method you're using. And it also depends on where you're sampling as well. So a lot of things have to be taken into consideration.
Who's doing it, right?
And who's doing and who's doing it, Chris?
Do you think that there's, as a follow-up, do you think that there's any variability that could be introduced by that lag time?
What would be, do you think there's variability based on lag time in the analysis?
I'm not sure what.
Like time holding the sample, or?
Yeah.
Well, there shouldn't, because it's held on, it's held on ice and transported, and then it's processed, held in the freezer, and yeah. So.
Oh, sorry. I mean, I think the sample processing in general is an important source of variability in the number you get out. I mean, people don't always talk about it, but I think it's an important source of variability. The holding time itself, I have a hard time seeing that as being one of the more important ones, I guess.
Joe, are you saying that the culture-based method will change, have more variability than the DNA does?
No, I'm just asking about the DNA test right now. And I guess one of the things that I think about a little bit is, if you're running a beach program and there are people sampling, and they might go out and sample 5 beaches and then take that water back to the lab and process the water in the lab. Other people might go out and filter right on the beach side and freeze that right there. So is there a possible variability between those methodologies when you're considering that most of the testing that we're doing is stored samples that we might get stored samples for a month and then production?
So the effect of operationally, do you process them immediately versus storing and holding, and does that change on a real world management decision?
Oh, I'm sure it can change. How much, I'm not really sure.
I'm kind of arguing the other way. If you're measuring DNA live and dead, it doesn't matter. Is the DNA going to degrade that much? Would a DNA sequence degrade that much?
Probably not, but I don't know.
So,
Yeah.
at least in the case of keeping-based studies, all the cultural CFU were done on the same day. And filtration also was accomplished on the same day, and the filters were stored at -20 until they were shipped out. Once we received those filters, we stored them at -80 degrees. So I do agree that there is a time lag between culturable and CCE measurement, but Richard, do you have any comments how that might really affect the overall?
That's very good. Very good question. Actually, most of the studies that have been done just like what Don did. People just for convenience. People, the holding time for the actual water sample is the same for QPCR and for culture, 6 hours. But it's considered that that holding time is till you get to the filtration step there. And then again, like Don and like a lot of studies that we've done, because where labs are, not at the site there, we make the assumption that once you've filtered the sample and frozen it, then it's sort of frozen in time there. Nothing's going to happen to it. And, we've actually have done some studies on the effect of freezing. And there is some potential for degradation of the samples, particularly at -20 degrees. But I think at -70, like Burley said, there's stronger evidence that the samples are really stable at -70s. I know that creates some problems for some labs that don't have access to -70. But again, those labs that are actually doing this testing would be doing it right that same day anyway. So, hopefully, like the -70 storage aspect is sort of the gold standard right now for if you're going to store samples for off-site analysis.
Another question.
Well, I just wanted to add that we have done quite a bit of QPCR, and we do it all on the same day as the cultures. So, and I'm sure other labs are doing that too. So while some of it is later, I can say we haven't done analysis of it, but anecdotally, if we store something or we do it on the same day, we get the same results. But most of our analysis has been done on the same day. We filter and then we run the QPCR on split samples. Yeah, on split samples. So,
okay. Any other
I think that where the biggest variability or both your results are going to come in is that I know that we're limited by time. You have to go out, you have to sample in the morning, try to get results to the public, to the beach managers on that same day to keep the bathers healthy. The fact of the matter is that once the sun comes out, once those people comes out, the variability in cloud cover due to, with Campylobacter, if you were to sample at 9 a.m. versus 1 p.m., the results are going to just differ.
So the diurnal variation is probably a more significant factor.
So you have no way to accurately predict.
Any other questions? Yes.
This is for Mr. Burch. That beach where you had high count of salmonella all the time, did you look at bird activity on those beaches?
No, not that. Oh, sorry. The question was, there was a beach where there were higher concentrations of salmonella, and did we look at bird activity on the beach? And to my knowledge, we did not. So. Oh.
I work for Greg, but we had that data.
Oh.
If you wanted, we were curious.
There you go.
Or that every time we were there, but I don't remember what beach it was. Which one was it?
Well, Point Beach had high Campylobacter.
Salmonella, is it Bradiero?
Yeah, it could have been.
The answer is yes, because Bradiero or Point
Okay.
Beach, they both have significant gall impacts.
I should say I'm like a late addition to the project, so I don't know everything that happened before.
Yes.
I just want to make one comment about this diurnal variability. And yeah, sure, it differs in the morning and the afternoon, but you could predict that. You could, I'm going to give a plug for modeling. You can put QPCR in a model as a variable along with sunlight, cloud cover, whatever, and get that afternoon prediction if you wanted to. The morning QPCR and then the afternoon environmental conditions. So it's doable.
So you could factor in the diurnal variation using your model. Yes.
So one thing to keep in mind is molecular methods, like QPCR, that it's likely to be less affected by sunlight and other things compared to the culture methods. In fact, with the epi studies, we did do collection in the morning and in the afternoon. We really didn't see a difference when it compared to culture methods, whether you were collecting in the morning or in the afternoon.
So with the molecular methods, they're less subject to the variance in diurnal conditions, is what the speaker was saying. Any other questions? Is there? You've asked us. Let's try and see if we got somebody else with a pressing question first. Yes.
Well, I don't know if anyone wants to speak to this, but just being going through this process now, converting to QPCR after doing membrane filtration for quite a long time, I see it's challenging, and I see challenges continuing going into the future with the person doing the testing and analysis. It's significantly easier to teach an intern how to do membrane filtration than getting into doing the QPCR. So being a person that's actually doing it, learning it, and breaking a few eggs along the way this season, I see that as a big challenge. Not a challenge that we won't overcome, but we don't really talk about that.
So the point the speaker was talking about is the challenge of doing the analysis. It's a significant processing, learning curve, et cetera, and that is something that we're not necessarily talking about. Is what does it affect in terms of our ability to make management?
And a good example is, a lot of us have seasonal employees,
And a lot of times they're housed. So we're going to have a very different quality of individual each season. You know, and their laboratory background will be very different. Those are the kind of challenges.
So the ability to train people on seasonal employees, that's certainly going to be an issue that we're going to have to face as a community. So we've got somebody who's very successful. So.
I just want to comment that at EPA, Rich has done through the program office of water as well. We did 2 trainings for 3 or 4 day training hands-on for folks that were interested in getting a more in-depth training of the QPCR method for Anthropogenic. One thing I guess I'm curious about is there interest in more such training?
So there was available hands-on training. The question is, as a community, do we want more hands-on training?
Yeah.
Lots of head nods.
Yeah. That variability. Yeah. Right. So I'm an optimist, and I thought, hey, QPCR is just pipetting, right? How hard is that? And you get an Excel spreadsheet from EPA. You just plug in the numbers, copy, paste. How hard is that? All right, so we have 10 new labs in Michigan, and so it's on me to help you be successful. So with Michigan State University, with Dr. Joan Rose, Dr. Aaron Dreeland, Dr. Tiong Ah, we are going to be working with Rich Hoagland and Kevin Oshima and others at EPA to put on some wet labs. It'll probably be this winter because we realize how much harder this is than what we expected. And I'm a little nervous about how much variability is in there with people that are running this and they're experts and they're getting variability. But regardless, here's our rapid test. We're going to go forward. And we have to because source tracking is next. So hurry and figure out these indicator bacteria because now we're going after the stuff that Tucker talked about. So we're moving on.
So we have about time for one more question.
Yeah, one last question.
Yes.
We tried to do a study of water quality on the sandbar at the south end of Torch Lake this last summer. And one issue is that sampling was done over a holiday weekend. The labs are not open on holiday weekends. So the issue of holding time before analysis is one we've been confronting. We would like to know where is the nearest QPCR lab that we can get to so that we can have this work better next summer.
Yeah.
So the issue of holding time, availability of lab, and when you're sampling over holidays when labs aren't open, you know, there's the availability of getting the information, and it is a challenge.
So here's a plug for Virtual Beach. So what happens is none of the labs are going to be open on holidays. It just doesn't happen. However, we have Donna Francie and Adam Mednick and others that have been really pounding their brains against the wall on this thing called Virtual Beach and the modeling. So what happens is, and even Richard Whitman is now modeling not just a beach, but a region of a shoreline. So you can get all of this information, tie it together with weather data and hydrological data, and predict what your water quality will be tomorrow. So you won't just worry about today, you can start predicting about tomorrow. And there's a whole bunch of talks on that. But to keep us on time, so you do not get mad at me for holding you up for lunch, we're done here. Thank you, Donalea. That was a magnificent job. Thank you very much. Yep, and our speakers. So thank you again for coming in. We're going to be back here at 1:30. But for now, go enjoy your lunch, and we're going to have a very interesting talk about 2 women in a canoe. Thank you. That was great. I'm going to turn this off.
Rich was saying some important stuff, and translating it is too hard.
Right. You did a great job.
So, you know.